Assalamualaikum warahmatullahi wabarakatuh, Doctor. My name is Ahmad Bukhari, student ID 906965. Inshallah, today I will be presenting to you assignment number 1, data analysis using SPSS. For today's presentation, this is the agenda, and if you see the agenda, it is aligned to the requirement of the questions within the assignment. So I will be covering data screening, and under data screening, I'll be talking a bit about unengaged responses, missing values, single outliers. And then I'll cover multivariate outliers, demographic analysis, reliability analysis, descriptive analysis, normality tests, correlation analysis, regression analysis, mediation and moderation analysis. Now moving on to the first part, which is data screening. Now the first key question is, why do we do data screening? If we look at the reason why we do data screening, first is identification of error. Data screening helps to identify error that might have occurred during data collection or data entry, especially because it could be influenced by human factor when we do incorrect entries, missing data, or out of range value. Second, assessment of missing value. Data screening can help to identify any missing value within a data set. Now, what it does is it helps us to understand the pattern of missing data that can help inform decision about how to handle these missing value. Third one is outlier detection. Data screening is crucial for detecting outliers. Outliers can influence statistical analysis results that could lead to incorrect conclusion if not properly managed. The next one is data normality. The normality of data is key assumption for many statistical analysis. Therefore, data screening can actually help us to assess whether this assumption is actually met or not. Next one is data cleaning. Data screening aids in data cleaning by identifying inaccuracies, inconsistencies, or even redundancies in the data set. And finally, it helps improve the validity of results. Ultimately, data screening helps to ensure the validity of statistical analysis and conclusion drawn from the data. Now, for this analysis, there are 3 data screening approaches that were used. Number 1 is unengaged responses, missing value, and also single outlier. Now, when we look at the data set that was provided, the conclusion of the unengaged response is there's actually a high engagement level. And the reason is the notable standard deviation in response to indicate active participation by the respondents, because we have all the sample, which is n equal to 145 participants who made up the sample, offered insightful and sincere response. Now when we move on and we look at missing value, among the 67 variables examined, only 8 contain missing responses. Now, if we look at the table, each of these 8 variables has 144 valid responses out of 145, indicating high completeness and reliability in the data set. Now, finally, when we look at single outlier, we look at HRM4, the majority of responses for the HRM4 variable are either neutral, which is about 35.2%, or strongly agree, which is 35.2%, and a minority of the participant either strongly disagree, which is 9%, or disagree, which is about only 3.4%. And also this shows that outlier has been detected. An outlier value of 34 was detected in the HRM4 variable. Now this is actually significantly outside of the expected range of between 1 to 5. Now this outliers requires careful consideration and examination in the analysis because it deviates significantly from other responses. Now moving on to the next slide. Now the next item that I will cover is multivariate outlier. If we look at this diagram, a multivariate outlier actually was detected in the dataset, and this is using the Cook's distance, suggesting it significantly influences the parameter of the regression model. Now, a multivariate outlier refers to a combination of scores on several variables that is not typical of the scores of those variables when compared to the rest of the data set. Now, these outliers are identified based on multivariate analysis, which includes multiple variables at the same time. Now, identification of multivariate outlier. A multivariate outlier is detected using Cook distance, suggesting that, again, it was mentioned earlier, it significantly influences the parameter of regression model. Now, this outlier could be the result of a data entry mistake or influential data points within the analysis. It requires more investigation and also measure. Now, it is critical for us to investigate the nature and the cause of this outlier to understand the impact on the overall analysis depending on the findings. Measures such as the data validation or sensitivity analysis may be needed to manage and influence this outlier. Now, moving on, demographic analysis. Why do we actually do demographic analysis? There are a couple of reasons. First, to understand the sample. It helps understand the characteristic of the sample that is being studied. Now, this includes attributes like age, sex, income level, education level, occupation, and other relevant variables. It also helps us understand a bit more on the generalizability by comparing the demographic of the sample within the target population. The person who is doing the research or the analysis can actually assess how generalizable the findings are. If the sample closely matches the population in key demographic aspect, it means that it strengthens the ability to generalize the finding. The next one is actually segmentation. Demographic analysis allows researchers to segment their data set based on these characteristics. For example, those who are doing the analysis might be interested in examining differences in behavior between different age group or genders within the same analysis. Next one is control variable. In research studies, demographic variables are often used as control variable. This allows researchers to investigate the relationship between the independent and dependent variable, which is more accurately by controlling for potential confounding factors. The final one is identifying pattern and trends. By examining demographic variable, person who is doing the analysis can identify pattern and trends that might be related to the variables of the interest. For example, a certain behavior might be more common in one demographic group compared to the others. Now, in this assignment, there were 4 demographic categories that we're looking into. Number 1 was group, gender, age, and also years of experience. Now, let me cover one by one. First, group. Now, based on the analysis, if you look at the table of the group, the analysis conducted, it was found that the sample used for the study consisted of 2 distinct groups, Group 0 and Group 1. Within the model, 82 respondents were classified under Group 0, representing approximately about 56.6% of the total participant. On the other hand, Group 1 comprised about 63 respondents, accounting to about 43.4% of the total sample. This distribution indicates that Group 0 had a slightly higher representation than Group 1 in the study population. Moving on to the next table, gender. Based on the analysis, it was discovered that the sample used for the study consisted of 145 participants in total. Among these participants, 76 individuals were identified as males, representing approximately 52.4% of the sample. Now, conversely, 69 individuals comprising approximately 47.6% of the sample were identified as female. Now, these gender distribution provide insight into the sample composition with a slightly higher representation of males than female. Now, moving on to the next table, age. From the analysis, it was observed that the sample used for the study consisted of 145 participants in total. The participants were categorized based on age distribution. 25 individuals accounting for approximately 17.2% of the sample were under 30 years old. 52 individuals, representing about 35.9% of the sample, fell between the age group of 30 to 40. 45 individuals, comprising 31% of the sample, were aged between 41 and 50. 23 individuals making up about 15.9% sample of the sample were above the age of 50 years old. This age distribution provides valuable information about the sample composition that allows us to understand the consideration based on different age group. Now the final table is the years of experience. Based on the analysis, it was observed that the sample size from the 145 responded, the participants were categorized based on their years of experience. 30 individuals were in the 1 to 5 years of experience, 6 to 10 years of experience were about 43, 11 to 15 around 22, and more than 15 years of experience there was about 50. Yeah. Now moving on to the next slide. Reliability analysis. Now, why do we actually do reliability analysis? Reliability analysis actually measures how closely related a set of items are as a group. It measures the internal consistency of a measure. A high reliability coefficient indicates that items of the measure have shared covariance and could have been summed up to represent a latent concept. In this analysis, Cronbach's alpha is the most commonly reliability measured in this regard. So if we look at the assess reliability reason, reliability analysis helps to understand if the same set of items, which is the question in the survey, if given to the same respondent at this different time would yield similar result. Now this assess consistency of the measure. The next one is validation of scales. Now, if we are developing a new scale or modifying an existing one, reliability analysis can help in validating these scales. Now, a scale that isn't reliable cannot be valid. And finally, item analysis. It allows the person who's doing analysis to understand the contribution of each item to the overall reliability of the scale and provide item specific reliability if each item is deleted. Now, let's look at each table, and I'll do a quick voiceover on the findings from each table. Number one, the reliability analysis that was done on the IT infra. Now, from this analysis, the calculated alpha coefficient was 0.889. Now, this indicates a high level of internal consistency among the item used within the study. Now, this suggests that the items reliably and consistently measure the same underlying construct. A higher alpha coefficient, closer to 1, indicates stronger internal consistency, indicating that items are more closely related and provide a reliable measure of assessed construct. Now, the obtained alpha coefficient of 0.889 suggests a robust level of internal consistency among the items, supporting the reliability and validity of the measurement instrument that is used in the study. Let me move on to the next table, which is IT experience reliability test. Now, if we look at the IT experience reliability test, the obtained alpha coefficient is actually 0.704. From the analysis, it suggests that the item used in the study exhibit satisfactory reliability and consistency. Now, while a higher alpha coefficient is generally be more desirable, a value of 0.704 indicates moderate internal consistency among the item. Now, this suggests that the items on average measure the same underlying construct with a reasonable degree of reliability. Now, I will probably skip the RA reliability test because we see the outcome is 0.839, which is closely on the score of the IT infra reliability. Maybe let me just move on to the final one, which is the HRIS reliability test. Now, looking at the HRIS adoption reliability test, the alpha coefficient is 0.907. From the analysis, it suggests that items utilized in the study demonstrate really high reliability and consistency. Now, this indicates a strong internal consistency among the items, indicating that they accurately capture and measure the underlying construct. Now, with a very high or a significantly high alpha coefficient, the measurement instrument used in the study considered very reliable, bolstering confidence in the validity of the results. Moving on to the next slide. Now, descriptive analysis. Why do we actually do descriptive analysis? Descriptive analysis, number one, it allows us to understand basic feature. Descriptive analysis allows us to understand the basic feature of the data and provides a brief description of the sample. Now, this includes measures like mean, median, mode, standard deviation, which gives an overview of distribution of the data. The next one is identifying pattern. Now, descriptive analysis or descriptive can help identify patterns and trend in large volume of data. They allow us to summarize and find pattern that may not be immediately obvious by just looking at raw data. Next one is data preparation. Descriptive analysis helps in identifying errors or outliers in the data set, which is crucial for data cleaning before proceeding to a more complex analysis. Next one is identifying relationship. By using descriptive analysis, we can actually begin to understand relationship between variables in a data set, which can form the basis of further statistical analysis. Informed decision making. Descriptive statistics provide the basis of which we can draw conclusion and make informed decision. They offer a way to present data in a meaningful and understandable way, which aids better in decision making. And finally, foundation for further analysis. Descriptive analysis is the first step before diving into more complex analysis, such as regression, hypothesis testing. Now, it gives person who is doing the research or analysis a good and better understanding of what additional analysis might be necessary or valuable. Now, if we look at the assignment that was given, there were a lot of tables that were captured in the report in terms of the descriptive analysis. However, for the purpose of today's presentation, I will cover two, which is IT infra and also IT experience. Now, if we look at the table of IT infra, the analysis reveals that the average of the variable IT infra is 3.817. Now, this average represents the typical central value of IT infra variable within the dataset, indicating that on average the value tend to center around 3.817. Yeah. If we look at the next table, which is IT experience, the analysis indicates that the variable tend to concentrate around the value of 1.857. This suggests that most data point or response are closely grouped or centered around this value. Now, the clustering of variables around 1.857 indicates a central tendency or a common characteristic shared among the variable that is being examined. Moving on to the next part. Normality tests. Now, why do we do normality tests? There are a couple of reasons. Number one, assumption checking. Many statistical tests such as the t-test, ANOVA, and also linear regression assume that the data are normally distributed. The validity of the results from these tests might be compromised if this assumption is violated. Now, therefore, if we look at the normality tests, conducting this is an important step in the data analysis process. It helps us ensure that the assumption of the subsequent statistical tests are met. The next one is understanding data distribution. So normality test helps to understand the distribution of the data. Now, this can help guide the selection of appropriate statistical method. If the data is normally distributed, parametric tests can be applied. If not, non-parametric methods might be more suitable. The third one is data transformation. If the data is not normally distributed, we might not need to perform some sort of transformation. For example, logarithmic or square root to make it normal or normal enough to conduct further analysis. The normality test actually will help us to know if such transformation is necessary. Finally, describing data. Normality tests are useful when it comes to describing the data. It allows us to use terms such as mean, standard deviation in a meaningful way since these measures are based on the properties of a normal distribution. Now, if we look at this table from the analysis of the assignment, one example that I would like to share in terms of the normality test is the IT infra. Now, based on the analysis, the null hypothesis assumes that the data follows a normal distribution, because we can see that it is indicated by the significant level of 0.000, which is less than the conventional threshold of 0.05. Now, in SPSS, when we perform the normality test through the explore option, where we can specify in our test whether using Shapiro-Wilk or Kolmogorov-Smirnov, the program or SPSS will provide a significant value. If this value is less than our chosen alpha, which often is 0.05, we would normally reject the null hypothesis, and the data means it is normally distributed. Moving on to the next slide. Now, correlation analysis. Now, correlation analysis is a statistical method used to evaluate the strength and the direction of the relationship between two or more variables. The outcome of the correlation analysis is a correlation coefficient, which is the value between -1 and 1, which represent the degree of association between the variable. Now, there are different types of correlation coefficient, which the most commonly used is the Pearson correlation coefficient. It is used when both variables are continuous and follow a normal distribution. However, if the variable do not meet this condition, other coefficient like the Spearman or the Kendall tau might also be appropriate. Now, it is important that when we have the correlation coefficient, we understand what it means. If the correlation coefficient is close to +1, it shows a stronger positive correlation. If it is if it is close to -1, it indicates strong negative correlation. And if the correlation coefficient is close to 0, it signifies no linear correlation between the variable. It is important for us to remember when we do the correlation analysis that correlation does not imply causation. In other words, just because two variables move together, it does not mean that one variable is causing the other to change. Other underlying factors might be influencing the observed relationship. Now, if we look from the assignment analysis, two of the tables that are highlighted in this slide is IT infra and also IT experience. Now, let's look first at IT infra. From the analysis, it is found that each item correlates significantly with one another. So if you look at IT infra 1 has moderate positive correlation with IT infra 2, which is 0.624, IT infra 3, 0.705, IT infra 4, 0.816, and IT infra 5, 0.620. Now, this suggests that IT infra 1 is moderately associated with the other variable in a positive direction. IT infra 2 has moderate to strong positive relation with IT infra 3, which is 0.769, IT infra 5, 0.632, indicating a relatively stronger relationship between these two variables. IT infra 3 exhibits moderate to strong positive correlation with IT infra 4, which is 0.617, IT infra 5, 0.782. Now, this suggests a significant association between IT infra 3 and these variables. IT infra 4 shows a strong positive correlation with IT infra 5, 0.480, indicating a moderate relationship between these two variables. Alright, so let's move on to the IT experience table. If we look at the IT experience table, the analysis, it shows that also there is a positive correlation between all items. Now, if you look at IT experience 1, has a moderate positive relationship with IT experience 2, 0.593, but a weaker positive correlation with IT experience 3, 0.520. Now, this suggests that IT experience 1 is moderately associated with IT experience 2 and somewhat associated with IT experience 3 in a positive direction. Now, maybe let's take one last example, which is IT experience tree. IT experience tree shows a moderate positive correlation with IT experience 1, which is 0.520, and a weak positive correlation with IT experience 2, 0.239. Yeah. Now this suggests that a moderate association between IT experience 3 and IT experience 1, while the association with IT experience 2 is actually a bit weaker. Now let's move on to regression analysis. Now, regression analysis is a statistical method used to examine the relationship between two or more variables of interest. Now, while correlation analysis measures the strength of an association between two variables, regression actually quantifies the nature of the relationship. What is actually the primary goal of regression analysis? So, the primary goal is to understand whether and how some variable, independent variable, predictor influence others, which is dependent variable, and also outcome. In simple terms, it enables us to understand how the typical value of the dependent variable changes when any of the independent variable is varied, while the other independent variable are held fixed. Now, there are a couple of types of regression. The more simpler and general one is the simple linear regression and also the multiple linear regression. The simple linear regression is the simplest form of regression. It examines the relationship between two continuous variables. It models the relationship by fitting a linear equation to the observed data, where one variable is considered as explanatory variable and the other as dependent variable. Multiple linear regression, in real-world scenario, we usually have more than one explanatory variable to predict the dependent variable. Now, in these such cases, multiple linear regression is used, which includes two or more predictors. Now, the output of regression analysis can be interpreted as follows. First, the regression coefficient tells us how much the dependent variable is expected to increase or decrease when the independent variable increases by 1, holding all other independent variable constant. Now, from the assignment, we look at the table here. Now, from the analysis, it shows a regression model was conducted, resulting in an observed correlation coefficient of 0.498. Now, an R value of 0.498 indicates a moderate positive correlation between the variable. The analysis revealed that an R-squared value of 0.248, which implies that approximately 24.8% of the variability in the dependent variable can be accounted for by the predictor variable included in the model. Now let's move on to the next slide. This is the last part of the presentation, mediation and moderation analysis. Now, what is actually mediation and moderation analysis? So mediation occurs when a third variable, which is the mediator, intervenes in the relationship between the independent, the predictor, and also dependent, which is the outcome variable. What happens is it mediates the relationship between the predictor and the outcome, explaining why or how the predictor affects the outcome. Now, for example, in a study to understand the relationship between stress and heart disease, so stress is the predictor variable and heart disease is the outcome variable, poor diet might be a mediator because stress might lead to poor diet, which in turn leads to heart disease. Mediation analysis helps to uncover the underlying processes and the causal mechanism. Moderation analysis occurs when the third variable, which is the moderator, modifies the relationship between the predictor and the outcome variable. Now, it tells us under what condition an effect occurs. The answer of when, for whom, an effect stronger or weakest. For example, let's say we are studying the effect of exercise, which is the predictor, on weight loss, which is the outcome. So when we find that the age of the individual moderator changes the strength of this relationship, younger individual might lose weight more quickly than older individual when they exercise. Thus, the age moderator, or the age moderates the relationship between exercise and weight loss. Now, both mediation and moderation analysis are fundamental to understanding complex relationship among variable, and it actually can be used across a wide range of field. So for this assignment, if we look at what has been done in terms of the analysis, in terms of the model, I will be explaining the outcome variable of HRIS Edu and also HR practice. Yeah. Now, when we look at the outcome variable of HR practice, the model summary or the outcome shows that the relationship between the predictor variable, which is IT infra, and the mediator variable, which is HR practitioner or HR practice, explains 11.52 of the variance in HR practitioner. The coefficient of IT infra is 0.2972, indicating that for 1 unit increase in IT infra, HR prac is expected to increase by 0.2972 unit. Now, this means that this coefficient is statistically significant because P is actually lesser than 0.001. Yeah. Now, for the next example, in mediation and moderation analysis, is looking at the outcome variable of HRIS Edu. Yeah. Now, if we look at the table, model summary, model, covariance matrix, and also the test, the model summary suggests that the predictor variable, which is IT infra in HR prac, explain about 21.23% of variance in HRIS Edu. For IT infra, the coefficient of 0.1622, indicating that for every 1 unit increase in the IT infra, it will be associated with a 0.1622 unit increase in HRIS Edu. This means that P is equal to 0.0118. For HR prac, the coefficient is 0.3389, indicating that a 1 unit increase in HR prac is associated with a 0.3389 unit increase in HRIS Edu, which P is lesser than 0.001. Now, the covariance matrix shows the covariance and the variances of regression coefficient for the constant term IT infra and HR prac. Now, additionally, there is a test of interaction between X, which is IT infra, and M, which is HR prac. The full test result suggests that the interaction effect is not statistically significant because the p value is actually 0.0708. So with that, I have reached the end of my presentation. I hope that I have covered clearly all the items that were required for this assignment 1. And I want to take this opportunity, Doctor, to say thank you because I have actually learned a lot on using SPSS. And if you have any further question, please do reach out to me directly. So once again, thank you so much, Doctor. With that, I will conclude my presentation for assignment 1. Assalamualaikum warahmatullahi wabarakatuh.